So lecture 45. So we'll start with a small definition, that is entire function. A function fz, is called an entire function if it is analytic entire complex plane. Entire complex plane C, right? So what is analytic function? हाँ बोलो.
जो डिफरेंशिएबल हो इन सम नेबरहुड ऑफ z नॉट.
यस, जो z नॉट के अलावा उसके नेबरहुड पे भी डिफरेंशिएबल हो उसको बोलते हैं हम एनालिटिक फंक्शन. ठीक है, मतलब एक पॉइंट पे ना होके उसके इर्द गिर्द एक छोटा सा नेबरहुड मिलना चाहिए जहां पे वो डिफरेंशिएबल हो, चाहे वो कितना भी छोटा क्यों ना हो. ठीक है, तो उस फंक्शन को बोलते थे एनालिटिक फंक्शन. अब सोचो सारे कॉम्प्लेक्स प्लेन पे ही एनालिटिक हो गया, तो ऐसे फंक्शन को बोलते हैं एंटायर फंक्शन, यानी वो हर जगह ही एनालिटिक है. अरे देखो स्पेलिंग ही गलत डाल दी एंटायर के. Okay, so there are few examples where the function is, of course, it will be every time it will be analytic, right? Complex polynomials, Ez, these all are the functions which will be analytic everywhere, right? So examples are polynomials, Ez, etc. Right? Is it okay? समझ आ रहा है ये चीज? बोलो.
यस सर.
Okay, so
Yes, sir.
next is harmonic function. Now this is important. Okay, so a function, we'll start with the real valued function, right? A real valued function f, let's say in two variables x and y, right, is said to be harmonic, is said to be harmonic on domain D, if two things should happen. What are they? That means fxx, fyy, fxy, fyx are continuous and it should satisfy the Laplace equation. It should satisfy the Laplace equation. That means fxx plus fyy is equal to 0. You'll be using the harmonic functions as a tool to prove that the functions are analytic as well. Okay, so what we're gonna do, so we'll be using this result, and that's what, if a function fz is equal to uxy plus iota vxy is analytic in domain D, then then components of f, क्या है component of f? u and v, right, are harmonic in D. So basically there is a relationship between the analytic function and its component. If the function is analytic, then its component must be harmonic. So if they are harmonic, what it means, u and v are possessing the second order continuous partial derivative. Further, they will both satisfy the Laplace equation. That means you will be saying that uxx plus uyy has to be equal to 0 and vxx plus vyy has to be equal to 0. Right? Are you with me on this? Okay? Yes.
Yes, sir.
Yes, sir.
Okay. So now we'll be moving towards an important concept and something we call it as harmonic conjugate. A function v is said to be harmonic conjugate of function u if what should happen? See, first condition, both should satisfy the Laplace equation. Okay, so first of all, what I'll say, u and v should be harmonic. So harmonic means what? They should satisfy this thing. Of course, their second order partial derivative should be continuous, but if they are harmonic, additionally they will also satisfy this Laplace equation, right? And secondly, what? They should satisfy the CR relationship, right? U and V should satisfy the CR equations. That means ux should be equal to vy and uy should be equal to minus vx. So our question will be like that. We have one function, we need to find out the harmonic conjugate of that function. So that will be precisely our question. Okay. So let's say, let's start with this thing. It's very easy. You'll come to know that how, easily this can be done. Show that uxy is equal to y cube minus 3x square y is harmonic. Further, find the harmonic conjugate of u and find the corresponding analytic function fz. Okay, so to start with the point, let's say do it point by point. So our first point is we need to prove that our u is harmonic. Can anybody tell me how to prove that u is harmonic?
Sir,
Yes.
Laplace condition.
Only Laplace condition. See, we don't need to prove that ux and uy, uxx, uyy are continuous. Why? Because we have a sort of polynomial over here. Okay, so polynomial in nature मुझे पता ही है कि इसका अगर मैं uxx uy करूंगा, so it will be another polynomial and it will be continuous, right? So in first part, I'll be proving uxx plus uyy is equal to 0, right? So let's start with this. So it is ux that is minus 6x minus 6xy, right?
Yes, sir.
And what is uxx? Minus 6y. Okay. And next is uy. So what is uy? 3y square minus 3x square. And what is uyy? That is 6y. So of course, if you add these two things, that means uxx plus uyy. So it becomes minus 6y plus 6y, which is equal to 0. So this means that u is harmonic, right? Are you with me on this?
Yes, sir.
Okay. So now, next part is slightly tricky. You need to understand it. Okay. Otherwise, everything is fine. It is slightly tricky. I wouldn't say that it's hard. It's slightly tricky. Okay. So next is you want to find out the harmonic conjugate of u, right? So that is harmonic conjugate of u. So what is harmonic conjugate of u? We understand this. पहला, अगर v उसका हार्मोनिक कॉन्जुगेट होगा u का, तो उसे क्या करना पड़ेगा? उसे एक तो लैप्लेस कंडीशन सेटिस्फाई करनी पड़ेगी, साथ में u और v को मिलके CR कंडीशन सेटिस्फाई करनी पड़ेगी, राइट? आर यू विद मी?
Yes, sir.
So we need to find out such v which should be harmonic and u and v together will satisfy the CR condition, right? So because we know that u is already harmonic, right? So we'll be only proving that v is harmonic. So secondly, what we'll be proving that v should be harmonic, and secondly u and v should satisfy the CR conditions, right? So let's start with the second condition. Now u and v should satisfy CR conditions. Therefore, so ux should be equal to vy and uy should be equal to minus vx. Okay, so what was your ux? This was your ux, right? So ux is minus 6xy. Okay, so minus 6xy should be equal to what? Vy. And here uy, what was your uy? Minus 3y square, sorry, 3y square minus 3x. That was your uy, right? So let me make a piece over here, and 3y square minus 3x square should be equal to minus of vx. You're with me?
Yes, sir.
Yes, sir.
Fine. Are you with me on this? Okay.
Yes.
So let's pick this equation only. Okay. That means your Vy is equal to minus 6xy. So what should we do? We should integrate both sides with respect to y, but since we are dealing with a partial derivative, so we'll keep x as constant. Okay. So integrate both sides, है ना? Treating x as constant. So you know that when you integrate this thing, right? So you'll get what? Here you'll get v. Here you get what? Minus 6xy का integral with respect to y plus some constant आना चाहिए. Are you with
Yes,
me?
sir.
But since we are treating x as constant, so this constant may include x as well, right? So we'll write it as phi x. That means some function of x. So what is the integral with respect to y then? That will be minus 6xy square by 2. Why? Because we are treating x as constant. Are you with me on this?
Yes, sir.
Okay. Yes. So your v will become minus 3xy square plus 5x. Now you will use this part, you will use this relationship now. That means you know that your Vx is going to be 3x square minus 3y square. Vx, I'm not talking about minus Vx, okay? So this is what, it now you differentiate with respect to x only, right? Differentiate partially with respect to x on both sides. So what do you get? Here you'll get Vx. Here you get what? 3y square. And what about this phi x? Can anybody tell me what about this phi x?
Sir, 5 dash x.
Exactly. Why it is phi dash x? Because this function contain only x, right? This function only contains x, not y. Okay. So taking a partial derivative or taking a normal derivative will be one and the same thing. Yes. Are you with me?
Yes, sir.
Yes, sir.
Okay. So now, but what were your Vx? Your Vx was, if you take the value of Vx from here, it will become 3x square minus 3y square, because we are getting the minus Vx over here. So we'll take we'll multiply both sides by minus 1. So your Vx will be 3x square minus 3y square. So you write it as 3x square minus 3y square minus 3y square plus 5 dash x, right? So this thing will get cancelled. Yes, you are with me?
Yes, sir.
ओके तो यहाँ एक और हमेशा ध्यान में रखनी है बात कि तुम यहाँ पे तभी ठीक हो अगर ये जो रिलेशन बचा ना इसमें y ना आए. ओके, देयर शुड नॉट बी एनी y in that. Are you with me on this? Since you are taking
Yes,
phi
sir.
x, so your other side should not contain y, right? Because
Yes, sir.
it should contain only x. Now, in order to obtain that phi x, what we will do, we'll simply integrate on both sides with respect to x. That means your phi x would be what? X cube plus c. Are you with me on this? Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Now this is your phi x and this is your v. So our aim was to find the harmonic conjugate of u, that is v. So of course, in order to get the value of v, what are you going to do? You simply replace the value of phi x over there. You'll get, therefore, your v is equal to minus 3xy square plus the value of phi x, that means x cube plus c. So remaining, you want to prove that your v is harmonic as well. So what are you gonna do? You simply check that Laplace equation, otherwise it is a polynomial, right? Everything is fine. So what is vx? That's what? Minus 3y square plus 3x square. Okay? And what is vxx? 6x. Now what is vy? So what is vy? Minus of 6xy. And what is vyy? That is minus 6x. So of course, if you add vxx plus vyy, so this will become 6x minus 6x will be 0. So this proves that your v is harmonic. Yes? Yeah, you're with me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So remaining, you want to find out that fz, which actually which will be analytic functions, and having u and v are the component harmonic conjugate of each other. So we know that this fz will be nothing but uxy plus iota vxy. Why? Because of this theorem. This theorem states that your fz will be analytic if these components are harmonic and they satisfy the CR conditions as well. So from this theorem, you have already, you know the value of u has already given to you. So that means y cube minus 3xy square, right? This was given to you. So y cube minus 3xy square plus iota. V you have already determined. So what is your V? See, that is your V, right? Minus 3x square y square plus x cube plus 3 minus 3xy square plus x cube. Let's make space over here plus c, right? So this is your final answer, FZ. So that will be the complete question. That's how we do this kind of questions. So let's do one more question. And so in the same way, we're gonna find out this. This is our uxy, which is given to us. That is log e x square plus y square, right? So what is ux? 1 upon x square plus y square into derivative with respect to x. That is what? 2x. Yeah. With me? सही है?
Yes, sir.
समझ आ रहा? And what is uxx? Now it will be bit difficult. X square plus y square whole square. X square plus y square as such. Derivative of x would be 1 minus x as such. Derivative of x square plus y square, that is 2x. Right? Since we are doing it partially. You're with me? So x square, y square minus x square 2 upon x square plus y square whole square. So that is our uxx. So what is uyy? So let's start with uy, that is 2y upon x square plus y square, and uyy will be, let's say 2 outside, x square plus y square whole square, x square plus y square as such, y will be 1 minus y as such, and that would be 2y, right? So now x square minus y square, okay? So uyy will be 2 times the x square minus y square upon x square plus y square whole square. So now uxx plus uyy, that is 2 times the x square minus y square upon, sorry, let's say first this y square minus x square upon this thing plus 2 times the x square minus y square upon this thing. Yes, you're with me?
Yes, sir.
So that is equal to 0. Okay.
Yes, sir.
So this proves that your u is harmonic, right? Now next part is you want to find out the harmonic conjugate. Okay. So harmonic conjugate. So what we're gonna do? We'll take ux first, and we know that ux should be equal to vy and uy is equal to minus vx. You can also start with uy as well. तो वो सारा फंक्शन y की फॉर्म में बन जाएगा, phi y, फिर एंड में phi y डिटरमिन करेंगे, उस तरह से बन जाएगा सारा. Okay. So now your ux. So what was your ux? That is 2x upon x square plus y square is equal to vy. And what is your uy? 2y upon x square plus y square is equal to minus vx. So let's start with this thing as we have done in the last question, and that was what? You will have this thing and you will integrate it with respect to y, right? So since your vy is equal to 2x upon x square plus y square, right? So integrating both sides keeping x as constant. So how are you going to get it? So that will be v integral of 2x upon x square plus y square dy plus some phi x. Right? So can you tell me what is that integral?
So 2x upon x square plus y square tan inverse y.
Tan inverse क्यों आ जाएगा भाई? सही है, tan inverse ही आएगा. So 2x तो कांस्टेंट ही आ गया. Tan inverse y upon x, ऐसा ही.
Yes, sir.
ठीक है. Is it okay? 1 upon a भी आता है ना. हाँ भाई बोलो जरा.
Yes, sir. 1 by x.
Yes. So your v will be this thing. So what are you gonna do now? Differentiating partially with respect to x. So what are we gonna get? Vx is equal to 2 1 upon 1 plus y by x का whole square into partial derivative of y by x plus phi dash x. So that is Vx is equal to what? 2 x square upon x square plus y square into minus y by x square plus phi dash x, right? So that x square and x square will get cancelled. Minus 2y upon x square plus y square plus phi dash x. That is Vx. And what was your Vx? Yes, your Vx was this thing minus के साथ, है ना? Yes.
Yes, sir.
Yes, sir.
तो यहाँ Vx की वैल्यू सब्स्टिट्यूट कर दें. Minus 2y upon x square plus y square is equal to minus 2y upon x square plus y square plus phi dash x. So this will get cancelled. So your phi dash x would be what? 0, right? You're with me?
Yes, sir.
ठीक है. So then your phi x would be what? Of course, c. And so what will be your v, right? So you started by this thing. That was your v. So you need to put phi x to be equal to c. So that means your v will be 2 times the tangent inverse y by x plus c. Yes. Are you with me on this?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
ठीक है. So we will prove that Vx and Vy, right? So you can prove this, I guess. So what do you prove? That V is harmonic. That means Vxx plus Vyy should be equal to 0. And finally you will write as Fz is equal to Uxy plus iota Vxy. So that will be the complete question. Yes. Is it okay?
Yes, sir.
Yes, sir.
Okay, so we'll be doing a few more questions in the next lecture, and that's it.